Hey everyone, this is Liz again, back with this video on learning C#. I did a cut after the last section because, had to do all that fumbling with setting up the Microsoft account, but that account's all set up now and we can continue. This is the Foundational C# course, which is essentially just a shim over the Microsoft course, but whatever. Um, so this is the second, I guess you could call it module in the course. This course has like 7 modules, and right now we're in this store and retrieve data using literal and variable values in C. That's what we're working through now. Also, just a quick aside, as I'm kind of going through the lessons, I've kind of been reading through the lesson text, just because I figure that's probably a little more interesting for viewers rather than just like me working in silence. But on the flip side, I'm also kind of trying to summarize it since a lot of the text is repetitive. So I don't know, just let me know in the comments, it's like, is the reading annoying, or should you want it to slow down and kind of go through it a little more? Just working out the kinks on how to handle this. So now we're on to using data. And I think we went to unit 2 of 9. We start with unit 1. Okay, so here basically it's just telling us, hey, we're going to be working with data. Sometimes it's hard-coded in applications. Hard-coded values are values that are constant and unchanged throughout the execution of the program. For example, you may need to print a message to the user when some of the operations succeed. A success message would likely be the same every time as the application is executed. So we're able to hard code something like that. Suppose you want to display a formatted message to the user containing different types of data. This message would include hard-coded strings combined with information your app collects from the user. To display the formatted message, you'll need to create both hard-coded values and define variables that can store data of a certain type, whether numeric, alphanumeric, and so on. In this module, you'll create literal values that contain different data types. You'll create variables that can hold certain data types, set those variables with a value, and retrieve those values later in code. And finally, you'll learn how you can simplify your code by allowing the compiler to shoulder some of the work. Yeah, I feel like, okay, this is probably some kind of typing thing where, yeah, it's probably related to typing. By the end of this module, you'll be able to create literal values and store and retrieve data in variables. So, creating literals for 5 data types, declaring and initializing. So, like with Python, there wasn't that separate declare and initialization, so I'll have to get used to that in this. Retrieving and set values in variables, and allow the compiler to determine the data type for your variable when initializing. Okay, let's see what it is. See, in this exercise, you'll print messages containing other data types and learn why types are so important to see. So what's a literal value? It's just a value that never changes. So previously you displayed a literal string to the output console. In other words, you literally wanted a string of alphanumeric characters. Use the string data type whenever you have alphanumeric words, phrases, or data for presentation, not calculation. What other kinds of literal data can you print to output? So we're printing different data types. So getting started, only need to know about 5 or 6. Just 5 or 6 to start. Oh, because I bet that there's like the different lengths, like with numbers, like int and then float, but then also double maybe. We'll see. If you only wanted an alphanumeric character printed to your screen, you could create, if you only wanted a single alphanumeric character printed to your screen, you could create a char literal by surrounding one alphanumeric character in single quotes. Yeah, gotta remember that. Single quotes for chars, double quotes for strings. Alright, So in the editor, doing right line. And B. Yep, so it made a B. Notice the B is surrounded by single quotes. Yep, yep. Enter the following code. We did that in the last lesson. You can't wrap a whole string in a single quote. Notice the single quotation marks. Yep. Just like string. So string is a data type. The whole word, not str like Python. So using integer literals. So we can do 2, 3. And I mean, presumably we can also do aha! Okay. Why didn't Control Enter work that before? But it does work now. Okay. Don't have to click the literal button. Nice. Alright, floating point literals. Floating point number is a number that contains decimal. Gotcha. Okay, yep. Doubles and decimals. So 3 data types for decimal numbers: floats, doubles, and decimal. And then the difference is precision, meaning how many digits after the decimal point. 6 to 9. So roughly, it's like estimate, roughly 6 to 9, roughly 15 to 17, and then 28 to 29. That's interesting. Okay. Here are the digits after the decimal. So right line. Okay, so then the F is a character that determines the type. So, oops. So we could do 0.25 F. Now Control Enter is not working again. Don't tell me I have to like be outside of the editor. That's weird. It literally was just working before. Am I hallucinating? Okay. We'll uncover that mystery over time, I guess. So, okay, F for float. And that char at the end of the number is a literal suffix. So we're telling the compiler what type. And it's case insensitive. So even though a float will give us 6 to 9 digits, it's not like it's going to render with the extra 4 digits in that console. What if I do this? One, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it cut it off. What if I do that's 35. So with a float, it should cut off to like 6 to 8. cut off at 8. What's the difference between double and decimal for the suffix? Okay. So notice the float type is the least precise, so it's best to use this data type for fixed fractional values to avoid unexpected computation errors. So if we're expecting huge number of decimal or places after the decimal point, float is not the best option. To create a double literal, just enter a decimal number. Okay, so it defaults to a double. So now we should see roughly 15 to 17 digits once I take this off. 3, 6, 9, 12, 15, 17. Okay. And then decimal is 28 to 29. And then M is for decimal because reasons. Got it. Yep, that's more. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 28. Okay. This all makes sense. Alright, using Boolean literals. Okay, so you can true or false. It's literally just lowercase true or false. So bool literal. Bool short for Boolean. Following lines of code to editor. True. Or spell it right, and false. I'm gonna figure out this key binding, but whatever. Okay, so when it prints, it's capitalized. Okay, the bool literals represent the idea of truth and falsehood. You'll use bool values to extensively. You'll use bool values extensively when you start to add decision logic to your applications. You'll evaluate expressions to see whether the expression is true or false. Why emphasize data types? Data types play a central role in CSharp. In fact, emphasis on data types is one of the key distinguishing features of CSharp compared to other languages like JavaScript. Designers of CSharp believe they can help developers avoid common software bugs by enforcing data types. You'll see this concept unfold as you learn more about C. Data types define capabilities. Earlier you saw strings and chars were used for presentation, not calculation. If you need to perform a mathematical operation on numeric values, you should use an int or decimal. If you have data that is used for presentation or text manipulation, you should use a string or char type. Suppose you need to collect data from a user, like a phone number or postal code. Depending on country, region you live in, that data may consist of numeric characters. However, since you rarely perform mathematical calculations on phone numbers and postal codes, you should prefer to use a string data type when working with them. Makes sense. The same can be said of bool. When you need to work with the words true and false in your application, you would use a string. However, if you work with the concept of true and false when performing an evaluation, you use a bool. It's important to know that these values may look like their string literal equivalents. In other words, you may think these statements are the same. We did this earlier. However, it's only the displayed output appearing to be similar. The fact is that the kinds of things you can do with the underlying interbool will be different than their string equivalent. Okay, that's like everything we just said. Yep, got it. Alright, declaring variables. So literal is literally a hard-coded value. Hard-coded values are the constants and unchanged throughout the execution of a program. However, most applications will require work with values that you don't know much about ahead of time. In other words, you'll need to work with data that comes from users, from files, from across the network. You need to work with data that isn't hard-coded. You need a variable. So, like, kind of we know variables. It's like you store value in it. They can change throughout the execution of a program. They can be read, assigned, changed. Name is usually human-friendly. Okay. Human-friendly label that the compiler assigns to a memory address. When you store or change a variable in that memory address, or whenever you want to retrieve the stored value, you just use the variable name you created. Got that. And it's kind of like domains to host IPs. It's easy for humans to remember. And it maps to an address the machine understands. Okay. To create a new variable, alright, so you gotta declare type. So first declaration, then initialization, and declaration requires type. So this we're working with variable for first name. And I guess, yeah, we're just doing camel case. Variable names, rules and conventions. Alright, can contain alphanumeric characters and the underscore. Can't use hash symbol, can't use $, which we normally wouldn't. I mean, PHP does, but this is not that. Variable names must begin with an alphabetical letter, or okay, can't start with a number. Case sensitive, makes sense, and can't be a reserved keyword. And like, we have a list of keywords here. I mean, I guess he has like kind of regular reserved words, like you can't use them at all, and then contextual keywords that, you know, it's not completely reserved, but, you know, the circumstances and how they behave differs depending on context. Alright. And then there are coding conventions. So these are actually enforced, but then these are like coding conventions that are just generally accepted. Okay, camel case is recommended. Name should begin with an alphabetical letter. Can use underscore for special purposes that we don't know at the moment, but they do kind of have a commonly understood meaning, but we're not dealing with that right now. Descriptive, yep, meaningful. Should be one or more entire words appended together. Okay, yeah, don't use contractions. And probably don't use a lot of abbreviations. And, oh yeah, don't use the data type. So we shouldn't have to say in the variable name that something's a string. That's interesting. I guess that was a thing that was advised, but no longer. Okay, so first name follows all those conventions. Here's some other examples. Camel case, words, they make sense. And so that's it about variables. Setting and getting values from variables. Sorry, I had to mute myself. I was drinking coffee. Okay, so yeah, variables are for temporary storage. They're meant to be written to and read from. So now we actually get to do something with a variable. Finally. All right. So we're just setting the first name. Hooray for completion! No output. What did I do? String, first name equals... Oh, no output. No output. Yeah, nothing's printed. Gotcha. That's the declaration and the assignment. First, if I just evaluate it, does it print? Yep, so you can't do that. So I'd literally have to print it. Gotcha, gotcha, gotcha. Okay, so declaration and assignment. Equal sign is an assignment operator. Colloquially, that's called setting the variable. Improperly assigning. Okay, so yeah, you can't go in that direction. Yep, it's going to complain. This, whatever on this side has to be a variable. Gotcha. Here's the interesting stuff. When you improperly assign a value that's not the correct type. This is the whole point of this, because they don't want you to be able to accidentally assign an incorrect value, because that can lead to bugs. Cannot implicitly convert int to string. You can't say like 10. Why am I getting the squiggly line? Oh, is it telling me ahead of time that it won't work? Yeah, nice. Okay. Okay, so this hints at what the compiler tries to do behind the scenes. It tried to implicitly convert the string Bob. This is if I were still in the first name example. Bob to an int, but it couldn't. Retrieve a value you stored in the variable. It's going to pick up the variable name, autocomplete that. Nope. Nope, it's not. It's not going to do that. Okay. That's cool. Yep. And then reassign. Just put it back to Bob. Yep. Initialize the variable. Set a variable to a value before you can get from the, okay. Modify the code you wrote to match the following. Okay, so you're just stating, or you're declaring it, but you haven't initialized it, and then you try to print it, and then you'll get an error. Gotcha, gotcha. Okay, interesting. To avoid the possibility of an unassigned local variable, it is recommended that you set the variable as soon as possible after you declare it. So that gives the error, but if I do this, then I've got the fallback. Yep. Alright, 5. Declare implicitly typed local variables. Okay. So the C compiler works behind the scenes to assist you as you write your code. It can infer your variable's data type by its initialized value. So all that typing stuff that we learned, you don't have to do it. Okay, that might be too simplistic, but it's just funny. Because maybe it does it for local. Okay, gotcha. What are implicitly typed local variables? An implicitly typed local variable is created by using the var keyword. Which is contextual. Interesting. Oh, it just takes you. Yep, okay. var tells the C compiler that the data type is implied by the assigned value. After the type is implied, the variable acts the same as if the actual data type had been used to declare it. The var keyword is used to save on keystrokes when types are lengthy or when type is obvious from the context. So, and presumably once type has been inferred off of the initialized value, you can't change it later. You can't assign a different type, I would think. Because the variable message is immediately set to the string value hello world, the compiler understands its intent and treats every instance of message as an instance of type string. In fact, the message variable is typed to be a string and can never be changed. Yep, that's what I thought. For example, we implicitly type it to string, and then we try to give it a default is the double is the default decimal. M means decimal type number. You're going to get an error. Cannot implicitly convert type decimal to string. Okay, other languages use the var keyword differently. In CSharp, variables are assigned a type by the compiler regardless of whether you use the actual data type name or allow the compiler to imply the data type. In other words, the type is locked in at time of declaration and therefore will never be able to hold values of a different data type, which, that's good. That, as you get the larger applications, and you're just passing data around to a bunch of different modules, you can lose track, and then you're sending in a payload that has a value that's of a different type from what you expected, but the person is sending it maybe didn't know that, and then further on in the program, some piece of logic tries to handle what it thinks is going to be an int, but it's actually a string, and then it wigs out and throws an error, and maybe you catch it and maybe you don't. Gotcha. Variables using the var keyword must be initialized, so you can't just declare them, which makes sense because you need the initialization to imply the type. It's important that the var keyword is dependent on the value. Yeah, it's just basically saying why you have to initialize. Why use the var keyword? It's been widely adopted in the C community, and it's likely that if you look at a code example in a book online, you'll see var keyword used instead of an actual data type name, so it's important to understand this usage. So I guess it's pretty widely used, a lot. The var keyword has an important use in C. Many times the type of a variable is obvious from its initialization. In those cases, it's simpler to use the var keyword. The var keyword can also be useful when planning to code for an application. When you begin developing code for a task, you may not immediately know what data type to use. Using var can help you develop your solution more dynamically. As you get started, it's recommended that you continue to use the actual data type name when you declare variables until you become more comfortable working with code. Using the data type when you declare variables will help you be purposeful in writing your code. Okay, so we told you about types. We told you about var, which makes types matter less, but then use types, which I get, and I do agree, and I understand they're trying to kind of help you develop a, a sense of discernment about types and coding, and how to how to kind of how to develop an idea of what types you need for which situations. So I get it. Um, Next unit. All right, now we're going to do a challenge. So you're writing, okay, so we're combining literal and variables into like some kind of formatted string. Gotcha, gotcha, gotcha. Select all of the code in the .NET editor and then select, okay, just clear it. Store the following in variables. So I don't, oh, okay, it's an email, some kind of status thing. So first name, message count, and temperature. Got it. And this is small, so that can just be float. So Bob, no, first name. And then what did we say? Message count. And temperature. Can I spell? Temperature. Yep. All right. So first name equals Bob. Message count equals 3. Gotcha. And temperature equals 34.4 float. These variables should be given names that reflect their purpose. Make sure that the type is correct. You'll combine the variables with the literal string. Passes into a series of, oh, they want you to use console write, so it's not really a formatted string. Okay. So hello. Hello. Can we concatenate? Yep. Hello, Bob. Oh, it's that. You have, wait. You have I mean, technically, then I could just do right line and just put all the, okay, whatever. Okay. You have n messages in your inbox. I mean, I guess just, we'll just do that. God, I'm just making a mess here. Okay. The temperature is Celsius. So, hello Bob, space, name, exclamation point, another space. You have something, and messages in your inbox. And the temperature is, yeah, that should be good. Yep, except I misspelled Celsius. There, okay. I like how that's working now. So, like, oh, did they tell me to use decimal? Okay, I could have used any of them. Okay. So, yep. Or they initialized and they declared initialized at the same time, which there was no reason why I couldn't do that. Yep, just one possible solution. You could have used more console write statements. You should have initialized 3 variables to store the 3 values. So yeah, I didn't. I did it separately. I'm a bad little ducky. Okay. Which of the following variable names must be avoided? Yeah, that. What is the problem with this line of code? var message, you need to initialize. Which of the following is the output? So it's a decimal. And yeah, it'll keep the 2 places. And which of the following lines of code creates a variable correctly? No. Like, yeah, why is this space here? And it's a float. I don't think that's going to cast. Yeah, that's not going to cast to bool. Why is this space here between the number? Okay. I got them all right. Okay. So I guess you can put a space between the number and the literal suffix. Didn't get that. Okay. Okay, your goal was to display a formatted message using a combination of literal and variable values. Using basic C syntax, you create literal values of several different data types. Okay, so like we did everything. Okay, past that module. Perform basic string formatting and see. Yes, I did that, and then I did. See, now there's no space. Okay, all right. You guys are just like messing with me. All right, I'm gonna take a short break, get some coffee, and hit the next one.